So first of all, I have to breathe a little bit because I just came out of the hands-on session. There's a green light, and I unmuted myself in Teams, so everything should be good. Okay, yeah. So today I'm talking about optimizing cap-to-cap communication with HCQL. So we'll learn this is all about in a minute. So first of all, a little bit about service-to-service communication between CAP services. So important, this is only about a CAP service talking to another CAP service, nothing about S4 or anything else. Then we have a code demo, and if some time is left, we can also have a little bit of a look into the CAP Java code that we have written for this feature. I better close the door. Yeah, so disclaimer. Everything needs a disclaimer. So all that you will see today in this session is unreleased software and important subject to change. Exactly. And the protocol and the integration, especially with the CAP Node.js stack, is under development. So things might change depending on the feedback that we get or any discussions we have. But what you'll see is the current development state. And this HCQL adapter will not replace OData in CAP. Yeah, so this is not, oh, you build a new protocol or network stack and everything has to adapt. It's just an additional possibility for an optimized way to have two CAP services talking to each other. Okay, so service-to-service communication. Imagine two services, two CAP services, and you somehow want to integrate them to each other or with each other. And normally in CAP, you do this with remote communication capabilities. But in the CAP code, this looks just like as if you would call just a normal CAP service. So this is Java code. I hope you can all more or less understand it. But basically, it's this is a service that you have just defined somewhere in your application. And you can take this service and get a CQN statement. In this case, it's just a CQN statement in the current execution context, and run it and get the result and return it to the caller. This code, it's totally transparent whether this is a remote OData or remote service at all, if it's OData, if it's something else. So on the remote call in the CAP service, especially namely Java, works in a way. So you have seen the CQN service before. It runs the CQN statement. Inside the runtime, we say, or we can detect whether this is a remote service or not. If it's not a remote service, it goes to the database. If it is a remote service, we check on the type. Currently, or for HCQL, it was only OData v2 and v4 services. So we detected that this is an OData service. And then the bottom part, we translate this to an OData request and take this OData request and execute it via Cloud SDK as an HTTP request to the remote OData endpoint. So it's, yeah, a little bit or quite some like conversion in between, and it's more complicated than it would need to be if you had only two CAP services, because a CAP service basically understands a CQL statement or CQN statement that we hand in here, but still we are converting it to OData and back from OData to an HTTP, and then back on the other side from OData to to CQL and then execute it. Then Daniel came up with the idea. Oh, hi. So Daniel just entered the room. Yes. end of last year or so, Daniel came up with the idea, why have all this conversion? Why not directly talk CQL between services or between CAP services? Yeah, so beginning of this year, we started a small implementation project, came up with the approach to detect or to have a new type, HCQL. We see this is a remote service, then we have a HCQL remote service, and then just hand over the statement without any OData conversion, just directly via Cloud SDK to the remote service. Yeah. This is what I want to show you in a demo. So can I somehow remove the PowerPoint on this screen so that I can just see the mirror? The end to show, right? Okay, so the first part of the puzzle is a CAP service. Or first of all, the scenario that I want to show you is incidents management. This is one of the demo scenarios that we have. And this is, you have incidents, and the incident can have a customer. So normally this is both in one service, but now I have two services, one incident service and one customer service. The customer service is the one that exposes now an HCQL endpoint where I can query customers. And the incident service wants to call this new customer service via HCQL. So in the VS Code that you can just see, I have the customer service. And in contrast to a normal Java application that would expose its service via OData, we now have, okay, this is a typical cut and paste thing. It's of course not OData adapter, it's the HCQL protocol adapter. Okay, so we have the HCQL adapter. And when this thing is starting, let's start it. You can execute requests pretty normal, or pretty not normal, but easily understandable requests with CQN statements against the service. So for example, now here we have a select statement. This wants to read or select from the customer service that is exposed here, and the entity customers, and it wants to read columns, like pretty standard stuff. Yeah, and then we execute it, and we get a JSON result with all the existing customers. And as CQN can do more than only selects, but also, for example, upserts. I've also prepared an upsert request that inserts new data. I've inserted a new customer. When you executed select again, you have this new customer in your database. This is the one side. So you basically now have an interface where you can, instead of OData requests, receive HCQL requests. And the other part of the puzzle is incident service. So here I also have added a new dependency. So for remote communication, I have now the feature remote HCQL. And let's look at it. have the incident service, which is not only exposing its own entity incidents, but is also exposing the customer's entity, which is taken from the remote service. You can see this here above. And as this is a remote entity, it's marked as with CDS persistence exists. That means if the service starts up, or basically even when it's compiled, no database tables are created for that entity, and no default handlers are listed at runtime. So this is just an entity that you could query, but the framework would not do anything by default. And for having this default behavior, by the way, this is everything that you would also have to do for a remote OData scenario. It's just the same from the application point of view. Yeah. So here we have the remote service. As I've seen in the showed in the code snippet before. And the remote service, we just execute the incoming statement and hand the result back. Basically the same code as you would have had before. But the difference is that the remote service is now configured differently as it would have been for an OData case. Now we just say it's not an OData service, but an HCQL service. Yeah. So let's start this application. Press that one. Application started. Again, I've prepared some HTTP requests. So here I have now called customers, which has on this local incident service, which has no own persistence, but is a remote entity. Yeah. And what happened is that my default handler that I've just shown before was executed, which called the remote service, which was configured as an HCQL service. And as a result, I get the same customers as I have shown before when querying customer service. Yeah, and what's also possible, where I've written some other code service before, I've also created a small action, create customers, also call, and I have a default handler for that one. And here again, the remote service is called with an upsert statement, similar to the one that I've shown on the other service before. And yeah, which basically creates a new customer out of the incoming values and then execute this with an upsert statement at a remote service. Get a new customer. Second. Querying the remote service again. You see new customers created. So everything worked. And one more moment. I think one more slide. Right. So what is the benefits, or are the benefits of this approach? HCQL. So first of all, it's runtime efficiency, because the whole OData conversion that is normally happening with remote OData services is just skipped. Yeah, you just create a HCQL string at Java or at runtime and then hand it over, and then the remote part is deserializing it on just executing it directly. And there are no functional limitations because it's just handing over HCQL directly and directly executing it. With the OData conversion, there is like there are scenarios that you cannot express in OData that are expressible in CQL, because CQL is more expressive than OData. But now with remote HCQL, you can just basically do anything that is expressible in the CQL language. Yeah. So this gives you in general more flexibility when accessing service. Yeah. Okay. That was the demo.